Every single time you use AI, whether you're asking it a question or generating an image, you're plugging into this massive, hidden world of physical stuff. Today, we're going to crack open the door to the engine room of the AI revolution and really see the true physical cost behind a single click.
So you type a question into a chatbot, and boom, seconds later, you get an answer. It feels instantaneous, almost like magic, right? But what's actually going on between your keyboard and that answer? Well, it's a massive, power-hungry industrial process.
In the heart of that process is in what you could call the engine room of our modern world, the AI data center. This is the place where all that digital code and data becomes something very, very real.
Okay, so what is an AI data center exactly? Come on, it's not just a big room full of servers. It's a hyper-specialized, high-density facility built for the absolutely insane demands of AI. And get this, it can suck down 2 to 4 times more power per square foot than a regular old data center. That single fact changes everything.
And here's why. Think about traditional cloud stuff, like your email or a website. The traffic is pretty steady, kind of predictable. A server rack for that might pull, say, 15 kilowatts. But AI is a whole different animal. It's not a jog, it's an all-out sprint. A single AI rack can draw up to 100 kilowatts. That is a gigantic leap in power. So all that power has to come from somewhere. And that creates this huge ripple effect, which brings us to the real heart of our explainer today, the environmental price tag of this whole AI revolution.
So that makes you wonder, right? When we talk about the cost of AI, what are we really talking about? What's the biggest item on that bill? Well, the first one, the most jaw-dropping one, is electricity.
Okay, get ready for this number. In 2024, data centers worldwide are on track to consume 256.6 terawatt-hours of electricity. I know, it's a number so big it's kind of hard to even wrap your head around.
So let's put it this way. That is enough energy to power 24 million American homes for a whole year. And because AI is growing so fast, that number is just going to keep climbing. We are talking about an energy appetite the size of a country. But here's the crazy part. Where does all that energy go? You'd think it all goes to the computers, right? Nope, that's only about 45%. A whopping 40% of all that electricity is used for one thing, cooling. Just keeping these machines from overheating. It's a constant battle against heat.
But the story doesn't stop with electricity. To fight all that heat, a lot of these data centers, especially the ones in warmer places, have to turn to another precious resource, water. A lot of water.
Check this out. A single big AI data center can guzzle up to 7.5 million gallons of water every single day. And think about it. A lot of these are being built in places that are already struggling with water shortages. Let's frame that another way. 7.5 million gallons a day, that's about the same amount of water an entire small town uses. So these massive buildings are literally competing for water with people, with farmers, with the local environment. And then there's what happens at the end. The race for better, faster AI means the hardware, those powerful GPUs, gets old fast. We're talking a lifespan of just 2 or 3 years. And that creates this ever-growing mountain of e-waste that's often full of hazardous stuff. So these things, the power draw, the water use, the waste, they don't happen in a vacuum. They happen in real towns next to real people. So when one of these giant facilities comes to town, the community has to weigh some pretty serious pros and cons. On one hand, yeah, you get some huge benefits. Thousands of construction jobs, a few hundred permanent tech jobs, and millions in tax money for schools and roads. But on the flip side, you've got the drawbacks. A constant, loud hum from the cooling systems, a major strain on the power and water, and losing land that could have been farms or homes.
And for the people who live there, this isn't some abstract debate. It's their real life. This quote, which really sums up feelings from communities all over, gets to the heart of it. How do you embrace progress without sacrificing the very things that make a place worth living in?
Okay, I know this all sounds a little grim. But the story absolutely does not end there. The massive scale of these problems is actually sparking some incredible innovation. People are working on building a much smarter, more sustainable way forward.
So to fix the water problem, engineers are coming up with some seriously cool ideas. You've got closed-loop systems, which basically work like a giant radiator for the servers. and they can cut water use by over 90%. We're even seeing experiments with zero-water data centers that literally capture their own rain to cool themselves.
And for all that e-waste, the big idea is moving to what's called a circular economy. That means designing hardware from the start so it's easy to take apart. It means pulling out valuable parts to reuse them, creating markets for refurbished gear, and even inventing new ways to pull almost all the precious metals out of old circuit boards.
So all of this leaves us with a huge question. AI is becoming a part of everything we do, and the physical infrastructure behind it is only getting bigger. The challenge for everyone, for tech companies, for communities, for all of us, is to make sure that the system powering this intelligence enhances our world without wrecking it. How do we build an infrastructure that's as smart as the AI it creates? That's the real puzzle we have to solve. Thanks for tuning in.